Hello everyone, and welcome to this example recording on source-free RC circuits. So the question we're going to be looking at reads as follows. For the circuit below, determine V0 for t greater than 0. So the voltage V0 is the voltage that we see between the two capacitors that are connected in series. Right, so what type of circuit do we have here? The source is disconnected at time t is equals to 0, so we know that we've got a source-free RC circuit. And with a source-free RC circuit where you've got a capacitor, you know that the capacitor, it's a voltage response that we're looking for. So the voltage as a function of time must then give us V0 e to the negative t over tau. So we need to get V0, we need to get tau to be able to solve this problem. Right, so how do we get V0? We know that at time t equal to 0 negative, the voltage source is still active. What happens to the capacitors? You know that the capacitors would effectively formulate an open circuit. That's 20 volts, that's 7 ohms, it's 5 ohms. Such current will flow in that direction. So we should be able to determine the voltage because we're looking for the initial voltage, which is the voltage from that point to that point. It should match the voltage over the 5 ohm resistor. We can use voltage division for that, so we can say V0 is going to give us 5 ohms over 5 plus 7, all multiplied by 20. So 5 over 5 plus 7, all multiplied by 20. And that gives us a value of 8.33 volts. Right, and then when time t is greater than 0, we need to take a look at the original circuit, and we can see that this whole part of the circuit will fall away, and all that will be left is the resistor and the capacitor connection. Right, and the resistor is 5 ohms, capacitor connection is 2 farads and 2 farads. So R equivalent, which is equals to RTH, must give you the only resistance that's there when t is greater than 0, which is 5 ohms. What about C equivalent? We've got a series combination of these capacitors, and you know that we're looking for plus minus V0, so the drop over both of them. If you've got a series combination of capacitors from the previous section or chapter, we remember that you add them as if they're parallel, so that will be 2 farads in parallel with 2 farads. Right, which is going to give you 1 over 2 plus 1 over 2, and that will be inverse, and that is going to give you 1 farad. That's the equivalent capacitance. Now tau is equals to RC, which is going to give you 5 times 1, which then gives you 5 seconds, and then finally V as a function of time is going to give you V0 e to the negative t over tau, which then gives you 8,33 e to the negative t over 5 in volts. And that's the final voltage as a function of time. Thank you for watching this video and enjoy the course.